This diagram shows the two lenses of a compound microscope. This is the objective lens, and this is the eyepiece lens. This is the principal axis, and these 2 points are the focal points of the objective lens, and these 2 points are the focal points of the eyepiece lens. Here is the object. In order to understand how the compound microscope magnifies an object and why the image is at a different orientation compared to the object, you need to apply the rules for drawing ray diagrams for convex lens. Let us look at the objective lens. The object is between f and 2f. Applying rules 1, 2, and 3 from the previous activity, you can see that the image will be here. Let us recall the rules. Rule 1 states that for any incident ray that is parallel to the principal axis, the emitted ray passes through the focal point. Rule 2 states that for any incident ray that passes through the center of the lens, the emitted ray continues in a straight line. And Rule 3 states that for any incident ray that passes through the focal point, the emitted ray is parallel to the principal axis. Now the rays intersect at this point, so you can easily draw the image as shown here. The characteristics of the image are: it is inverted, it is real because it's formed by the actual intersection of rays, it is larger than the object, it is located on the opposite side of the lens compared to the object, and it is located beyond 2f. Let us now look at the eyepiece lens. The image of the first lens forms the object of the second lens. As you can see, the object of the second lens is between the focal point and the center of the lens. Now, you can use rules 1 and 3 from the previous activity to determine the location of the image. Using rule 1. For any incident ray that is parallel to the principal axis, the emitted ray passes through the focal point. Using rule 3, for any incident ray that passes through the center of the lens, the emitted ray continues in the same straight line. As you can see, these two emitted rays will never intersect. However, if you extend them in the opposite direction, they will intersect at this point, and you can easily draw the image as shown here. Now let us determine the characteristics of the image compared to the object at the objective lens. As you can see, the image is virtual because it is not formed by the actual intersection of rays. It is located on the same side as the object. It is larger, and its orientation is opposite to the orientation of the object.